Hello again. As I promised, I will have another session on couples. Last time we did a couple of examples. Yeah, a couple of couples. Today we are going to work a third example because there was an example I wanted to print out and it didn't come out. So I did that. And then we are going to go over one last thing in couples that is worth mentioning. So this is a 2D couple. If you look at this system of power of forces, we have two parallel forces of magnitude 150 pound, and each one is making an angle of 30 degrees to the horizontal. You see they are equal, opposite, and parallel. That's the definition of a couple. As well as another couple here, 300, that makes a slope of 4/3 or negative 4/3, well, basically it's negative 4/3. But the idea is we want to find the magnitude of the couple. There are two couples here. So one way to do it, we know that the couple is a free vector. So, and since both of them are rotating clockwise, so they will be producing a negative k moment or a negative moment that goes into the z-axis, not at a specific point, at any point. The idea is how do we solve that? Okay. The first thing that people usually say is try to find the vertical uh, force, or I'm sorry, the vertical distance between each couple and then multiply the force by that. The problem is it's not hard, but that's basically, you know, there is an easier way to do it. I want you to look at how these are located. If I look at this couple, you know that I can resolve these two forces into their components, right? So if I resolve this force of 150, I will get a horizontal force of magnitude 150 cosine 30 and a vertical force going down of magnitude 150 sine 30. For this guy, I have 150 cosine 30 to the left and 150 sine 30 up. But guess what? Do you see that these vertical forces cancel each other? So I don't even have to say 150 sine 30 or 75 pounds. It doesn't matter. They cancel each other. Likewise, if I look at the other couple, I resolve this force into a horizontal component. Notice the horizontal is 3, the vertical is 5. So 3/5 of 300. 300 over 5 is 60 times 3 is 180. So I have 180 pound to the right and 240 pound down, which is 300 times 4 over 5 or 0.8. Likewise, I have 180 going to the left, canceling the 180 going to the right, and then 240 pound going up. And now the problem becomes so easy. I can say that the moment equals, first of all, that both are rotating clockwise, as we said. So it's a negative 240 times 2 and negative again, because the other one is rotating clockwise, 150 cosine 30, which is radical 3 over 2, times the perpendicular distance between them, which is also 2. So the 2 and the 2 cancel, and you get negative 480 minus 150 root 3 foot-pound or pound-foot. Okay, so we say 480 plus 150 root 3 equals, so the moment here is negative 739.8 foot-pound or pound-foot. Or some people, instead of writing it like that, they write it as 739.8 foot-pound, which is not nice, but and then they show you a clockwise arrow. So the clockwise meaning it's negative. Or if you want it in vector form, you would say 739.8 K foot-pound. And here you have to say, in that case, you would say, this is my X, this is my Y, and that's my Z. Or usually, yeah, something like that. So we know that the moment is about the Z axis and it's negative. Some people, when they do it, also, they can draw it like that. So if that's the Z axis, let's use a different color. And the way they show it is two arrows. Two arrows is a moment instead of a single arrow. So you draw it two arrows, and then the rotation is clockwise. Notice if it's clockwise, the arrows are going up. If it were in so that would be a positive. So if we want, I just wanted to show you how it's drawn, not this particular one. This particular one would look something like that. If this is the X, this is the Y, and that's the Z, we draw it as an arrow going down, double arrows, and then it's clockwise. So that's why clockwise is going down. So we draw it as a clockwise, like that. Okay, and that would be 739.8 foot-pound. And of course, this would be the other way around. If I draw it going up, then it should be counterclockwise. This is the generic one. It's not this problem. This problem, you can draw it like that, or you can write it in vector form, or you write it as a negative without being like a vector. Or you say it's this magnitude, but it's clockwise. So the clockwise or the negative mean the same thing. We also always prefer either this or that. And then if you want to show it on the figure, you have to show it, like with a double arrow. It's enough to say going down, right? Because clockwise meaning goes down. So some people show that like a circle, like almost a circle with an arrow. This is going clockwise, so it's driving. So you see, if you rotate the clockwise, the bottle cap, it will move down, meaning it's tightening, or the nut will go down. You are tightening the nut. Okay. The second topic, this is a short lecture because it was like a continuation of what we did before. The second, and this one will be important in courses like structural analysis or mechanics in the future that you take, like, for example, you take a course, as I said, in strength of materials or structure analysis or stuff like that. And the case would be something like, okay, that's what we are going to cover next, is that you have some kind of a beam, like a support. This is called a cantilever beam. It's just fixed on one side and it's free on the other. Okay? And then you have a force here. Let's take a very simple example. A force of magnitude 50 pounds, and it's maybe whatever, 4 feet away. 4 feet away from the support. And we want to see, what does the support feel? Okay? Usually you can see, later you will learn that, is that since this is pushing down, the whole thing is being pushed down by a force of 50, right? But this force is also producing rotation, a moment, a clockwise moment about this support. So this support is feeling a force pushing it down, and something wants to rotate the whole beam clockwise. We can replace that, okay? So we can replace this system with a similar system as follows. First of all, you know, when you have an equation like x plus 3 equals 7, and they tell you subtract 3 from here and subtract 3 from there, it's like you are adding and subtracting at the same time. Or when you do in algebra, completing the square. So they give you an equation and you say, okay, to make it a square, I need to add 4, but then you have to subtract 4 since you added the 4 that wasn't there anyway to begin with. That's what we are going to do. You see that force of 50 pound? It's there, right? So you say, okay, I will go to the support because I need to know what the support is feeling. Okay, and then I'm going to say, okay, so let's add a 50. But if I add a 50, I have changed the system, so let's subtract a 50. So I'm going to apply a force of 50 pound going up and another one going down so that I didn't change the system. So it's as if I took this 50 from here, moved it there. But by doing that, I created a couple, a clockwise couple. Do you see that? So now I have two things instead of one. That was just a force, but it wasn't applied at the support. So I don't know how do I how do I design the support? What forces act on it? And when I say force, I use it in the larger meaning, forces and moments. Okay. What forces does this support feel? In order to see it, I'm saying, oh, I wish the 50 was here. So I say, yeah, okay, move it. You say, but if I move it, I change the system. Okay, move it by adding and subtracting the same force. So now I have moved this 50 from here to here. And by doing that, I created a couple. 50 times 4, which is 200. So basically, that system, you see how easy it is? Now, that system is feeling a 50 pound here, and it's also feeling a couple of magnitude 200 foot-pound. 50 times 4, that's a couple. It's a free moment, so I can place it anywhere I want. So I place it here, and I say this support now is feeling 50 pound down. Yeah, I knew that because if it's down, then this one also is feeling it, right? It wants to take the beam and move down, so the support has to reject that. So it's rejecting 50 pound, and also it's rejecting a couple. And you say, why did I do that? So I know that if I take some of the forces in the y, like I did with particle, then here there would be a 50. And if I take the moment about this point, 50 times 40 is a negative 200. Yeah, I know, it's the same. But this is an equivalent system to this force. This was just a force, but when I move it as a force and a couple. Let's take an example and see how we are going to do that. So here I have a beam that is subject to three forces, one vertical, one incline, again 30 degrees, and 3, 4, 5. They are very common. And I want to replace them with just one force and one couple at A. So if I draw A, I don't want to see anything else. What is here? Okay, So let's do that. Let's take each force by itself. Let's say, first of all, the force at A is just the sum of those. So horizontally, so if I say FAX equals, FAY equals, and then the moment at A equals. I want three things. So force is in the X. This one is vertically, doesn't have an X component. This one, sine 30 is the horizontal. Why? Because they give you the angle between the force and the vertical. So the cosine will give you the vertical, which is the same as saying this angle is 60. Cosine 60 is the same as sine 30. It's 1/2. So I have 20 pound going to the right, correct? This one doesn't have. This one is 100 times 3/5. So plus 60 pound equals 80 pound. So there is a force of 80 pound here. I can draw it here and say 80 pound. Vertically, I have 200 going up. 200 pound. I'm not going to write pounds now. I have a vertical component which is 50 cosine 30. So plus 50 cosine of 30. And then I have one going down, which is 4/5 of 100 or 0.8 of 100 or 80 pound. So that equals, this is 120 plus 120, which is the 200 minus 80, plus 50 cosine 30 or √3/2. So you get 163.3 pound going up. And this is just the support. Finally, I need a moment. And all the moments are in the Z direction, right? I have the 200 going counterclockwise, so it's positive 200 times 3. The 50 has a horizontal component that doesn't produce moment because it passes through the support, and a vertical one, which is 50 cosine 30, going counterclockwise, so it's positive 50 cosine 30, which is √3/2, and that distance is 9. 3 plus 3 plus 3 times 9. On the other hand, this guy has a horizontal component that passes through A, so it doesn't produce rotation, a vertical one, which is the 80, but this one is going clockwise, so it's negative. So minus 80 times 6, 3 and 3. So I get 600 minus 480, that's 120, plus 9 times 50 is 450 over 2√3, or 225√3. So I get 120 plus 225√3, which is the same as 450 cosine 30. I get 509.7 foot-pound, and it's counterclockwise, meaning positive. So really, I have, I replace those with a moment in this direction of 509.7 foot-pound. So I replace this whole system by a single force. Of course, it's X and Y, but you can find it as a resultant, as a force going like that, and you can find the angle that it makes with the horizontal or the vertical. So it's not that hard. You can say it's the square root of 80 squared plus 163.3 squared equals, so this resultant R, so this is R equals 181.84 pounds. And what angle does it make with the horizontal? The y is this. So you can say inverse tan y over uh, over x, which is 80. There is no reason we can say 80. So it would be over 60 something, 65 or something, 63.9. And you can say, and you can write it like that, 63.9 degrees. So that's the force, that's the couple. So a bunch of forces can be moved to a new location as a single force and a single couple. Okay, and that was the last thing we wanted to cover in couples, is that how do you transform a force into a system of if the same force but at a different location along with a couple, because that may help us later in our analysis. That was it for today. I hope it was easy. Again, if you have any questions on these two examples, uh, don't hesitate to jot me a note on in the comment section, and I will get back to you as soon as I can. Thanks for your watching, and hope to see you soon. Thanks.